Today we'll try out a simple problem where you're given a number A and you're asked to swap its odd and even bits. For example, let's take A to be this binary number that has this binary format. The goal is you want to transform this to something like an A prime, which has its bits swapped in the sense that the odd bits take the even bits positions and vice versa. So now if we take an example here, let's pair them up. You can see that there are two pairs. There are four pairs. So you have bits in the first pair, they're swapped. Similarly, in this pair, they're swapped. In this pair, they're swapped. And the swap is a degenerate case where the swap is the same as the initial value. So now, using this as an example, we can look at what are the possible values a pair can take and what the transformations would look like when you do the swap. So here are the possible values. So if you look at pair 1, it was 1, 0. So if you look at pair 3, it's 0, 1. Pair 4 is a 1, 1. There's the fourth possibility is 0, 0, which is not there. So these are the four possible values that a pair can take. And you want to go from 1, 0, you want to 0, 1, 0, 1, 2, 1, 0, 1, 1. It's going to be the same. 0, 0, it's going to be the same. Right. Now if you look closely, the transformation here is essentially an XOR with 1, 1, the same here. In this case, it's a XOR with 0, 0. And in this case as well, it's an XOR with 0, 0. So the idea is that you look at each of these operators and figure out, okay, which of these can help me go from here to here, right? And so the value, the operand that you use will vary based on the value each of the pairs. So now this should give you a basis for a brute force algorithm. Let's talk about it. The idea is very simple. You would start with the first pair, figure out what the value of that first pair is, and then depending on the value, you would figure out which XOR operand you would want to choose. So in this case, if it's 1, 0, so you would pick 3, which is 1, 1. In this case, it's 1, 0, you again pick 3. In this case, 0, 1, you would pick again 3. If it's 1 for the fourth pair, since the even and odd bits the same, you would pick 0, 0. So let's use that as a basis to write an algorithm here. So the simple algorithm, let's define the prototype here. Returning an uint. The function is called a swap. Takes a uint a. Let's define. So the idea here is that you want to iterate through all pairs, right? So you want to define a variable called int numpairs. Saying size of a star 8 over 2. So size of a returns the number of bytes that's used to represent a, and then you're converting that to the number of bits, and then you're pairing that up, and hence this math here. So it defines intermediary temporary variables. I call them uint. One is for the result. The other one is for temp. Now the idea is to iterate through all pairs. For int 0 less than numpairs plus I. So Now here's the math. Here's the magic. So essentially, you need to extract out each pair. The pair that is formed by the least two significant bits of A. And then what you could do is you examine the value. Based on the value, you pick the corresponding operand for the XOR operator. Then you swap it, and you write it. You would put that and you store that in the result variable, and then you would shift a right to get the next pair that you want to examine, and repeat. So when you write it to the result, you got to make sure that you offset the bits that you're writing to by the corresponding position of the pair in the original number A. So here's how it would look like. So you would initially you would shift A by 2 positions. So initially I is 0, so you're not doing anything. And then you would actually put the you would want to extract out the lower 2 bits. So the way you do that is do an AND, logical AND with 0, 3. And you would do some checks on this value. So the check would be to see if temp is not equal to 0 and temp is not equal to 3. You would do, so if it's not these 2 values, then you would do a swap with 0x03, else you would just return P. Sorry, this is temp. Else you would just return temp, right? And now you got to store this temp. So you have the temp now. What you've done is you've extracted this value 1 0. So now A, the value in A. Let's look at this. I is 0. I'm just writing just doing a snapshot to see what these variables are for, say, the current iteration where I is 0. A is going to be as it is, which is 1 1 0 1 1 0 1 0, and then temp is going to be the last 2 bits, which is 1 0. And now in this case, temp is going to be 0 1, because you did a swap by virtue of this expression and picking the corresponding XOR operand. Now you got to store this value in the result, which is here. So let's define that. So result would be so here what you've done is essentially you want to offset the value in temp by the position of the pair. So that's why you would have to shift temp left by the paired index that is defined by I, and it in the result and store it. Correction here, this should be an OR, since you have to OR this, logically OR this, and then store it in the result. And then once you're done with the iteration, so you go back again, you start with I equals 1, so you shift right A, so you shift right A by 2 spots, and so you would get A as 0 0 1 1 0 1 1, 0, and then extract out temp, which is in this case 1, 0. You would again get the same values, 0, 1, and then store the result, and so forth, so on and so forth. And ultimately you would return the result. So this would work. This is just a very brute force way, but notice that there are a whole bunch of other operations that have to go through to get this to work. Now if you think a little bit more, there is actually a better optimal way of doing it. So I'm just going to put down the optimal way. Fortunately, it's very simple, but it takes fewer number of steps to get to the result. Now, the way to do it, now let's just write it down again. Event A. So the idea here is that you fundamentally want to extract out the even bits, and then you want to extract out the odd bits, and then you want to shift the even bits right by one position, shift the odd bits left by one position, and then do an OR. The way you do that is the following. Define odd bits assign 0x. So if you use this mask 5555, it will give you all the odd bits. Now, if you logically AND A with 0xAAAA, it's going to give you all of the even bits. And then you can do a little bit of bitwise sequence of bitwise operations here to yield a result, which is you do odd bits, you shift them right. You shift them left by one position, and then you would OR it with even bits, shift to right by one position. So, and this would be your answer. So notice how simple this optimal solution is compared to the brute force. I mean, both they yield the same result, but this is a lot better. Now, a quick note on the optimal approach here is that the reason why you shift odd bits left by one position is that if you do odd bits right by one position, what happens is you would lose out on the least significant bit. So that's why you would do left shift. Similarly, if you do even bits, if you shift the even bits left by one, then you would lose out on the most significant bit. Hence you would go with this option. That's about it. Thanks.